Hello there. Now by using the conservation of energy, we are trying to solve and find out the different field parameters. As you know, velocity or acceleration only we are going to be calculating the so far, right? And here whereby using this potential energy and the kinetic energy, then let me see how we are going to solve this problem. A ball of mass m, right, is dropped to a spring of stiffness k, right? The ball has a mass is going to be your m and dropped on a spring of stiffness k. This is the spring, the position from a height h. This is your spring and I have taken that as a reference. Then the ball is going to be taken at a height of h. Find the deflection of the spring if the ball is brought to the rest, right? And we need to find out the deflection of this ball. What is the deflection? And before bringing to the rest condition. Now how we are going to solve this problem? There we can see it has a certain height is there. It means that it possesses some energy at certain height. Alright? That I am going to be taking E1 is equal to E2. What is the E1? That is energy possessed for the position 1. E2 means energy possessed at the position 2. Right? So then how we are going to be taking this one? So this already we do have taken the PE1 that's going to be kinetic energy at position 1, that is equal to potential energy at 2 plus the kinetic energy at 2 we are going to be taking. Right? So if I am going to be writing these equations all here, what I am going to be getting at the position 1, what is the kinetic energy of that object? It's going to be 0. Only it possesses the potential energy that I am going to be taking m, g, h I am going to be taking. Alright? So that is equal to mgh. That's equal to, what is the potential energy at position 2? Can you see? This is the reference, it got the deflection. That I am going to be taking m, g, del I am going to be taking at position 2. Because this already we do have taken the potential energy over here. And at position 2, this is the deflection of the spring. That is the possess the potential energy. Plus, and what is the velocity of this one? That is equal to, that is going to be your kinetic energy. In this case, I am going to be taking here, that's going to be half k into del square I am going to be taking. Alright? So, that potential energy it is going to be possessed here and here is going to be mgh and mg del. At the same time, here is going to be the spring energy, it is going to be possessed. So that I am going to be taking here into half k del square. So we will simplify this equation. How we are going to be simplifying this equation? That I am going to be taking here half. So that means the 2 LCM I am going to be taking k del square plus 2 into m g del minus mgh is equal to 0. Right? These quadratic equations we are going to be solving by the equation of that. That's going to be del is equal to minus b plus or minus square root of b square minus 4ac by 2a equations we are using. In these equations, if I am going to be substituting here, so we are going to be getting the value. What is the value here? So that's going to be del is equal to minus b means here the minus 2 m g plus or minus the square root of b square means 2 m g whole square minus 4 into a is equal to k, and so that 4k into c minus of mgh I am going to be taking divided by 2 into a, that's going to be k I am going to be taking. So there we can see in this simplification that is equal to minus 2 mg plus or minus, so here 2 square is going to be 4. Alright. So then I am going to be taking to the outside means here also 2, the square root of m square g square minus onto minus plus k here mgh I will get it divided by 2k. Further simplification, 2 will going to be cancelled out. So del is equal to minus of 2 mg plus or minus. So here 2 already cancelled. That's going to be minus mg, the square root of m square g square plus k mgh divided by k we are getting. So this is going to be the deflection of the spring. So here the small modification, already we did the LCM, it means that minus 2 mg we will get it. So here is also the 2, and after taking out also 2 we are going to be getting. The final equation del is equal to minus mg plus or minus square root of m square g square plus 2 into k mgh divided by k. This is going to be the deflection of the spring. By using the law of conservation of energy, we can calculate it. I hope you are able to understand. So still if you feel any difficulty, please put in the comment section so that I can reach you out. Thank you.